Let's do question 4. An object in SHM oscillates with a period of 4 seconds and an amplitude of 10 centimeters. How long does the object take to move from x equals 0 centimeter to x equals 6 centimeters? So I'm going to give you a time to pause the video if you want to try it on your own. So the data that we could gather from the problem was that t, which is the period, equals to 4 seconds, and the amplitude is 10 centimeters or 0.01 meters. We can quickly calculate omega by having this information. The formula of omega is omega equals 2 pi over t. So let's just plug that information into the equation. Omega equals 2 pi over 4 seconds, which gonna give us pi over 2 rad per second. Let's just write our formula of position as a function of time, x as a function of time, amplitude times cosine omega t plus phase constant. Why did I write this question? Because we could so far calculate a few of these variables. We have the amplitude, we have omega, we don't need to find t because t is a variable. We need to find phase constant in order to find out how long does it take from particle to move from 0 centimeter to 6 centimeter. How long does it take? Let's just start by time 0. At time 0, the object is at 0 centimeter. We have the omega, which is pi over 2 radian per second. We have the amplitude of 0.10 meters. Let's just plug it into this equation to find the phase constant, because after finding the phase constant, we can place x equals 6 centimeters into our equation and find out t. That t allows us to find out how long does it take for the object to move from position 0 centimeter to position 6 centimeter. Let's do it together. So at time equals 0 second, the object is at 0 centimeter equals, the amplitude is 10 centimeters or 0.0 meters times cosine of omega t. Well, at time equals 0, no matter what is omega, is gonna be 0. So we are not gonna bother ourselves to write the omega t or 0, whatever. We're just gonna write out the phase constant. Let's find out the phase constant. Here we are going to divide 0 by 10 centimeter equal cosine of phase constant. Then we move cosine to the other side and it becomes arc cosine of 0 equal phase constant. It will give us positive negative of 1.57 equal phase constant. 1.57 equals pi over 2. So now we have to find out whether it's a positive or negative pi over 2. From the question, we understood that the particle is at 0 position, 0 meters, and moving to 6 centimeters. It means that it's moving to the right side. So it's better to choose minus pi over 2. Why? Because I'm gonna draw the reference circle for you to better explain the situation visually. So pi over 2 is here, minus pi over 2 is here. Here is our right side, and here is our left side. If we choose pi over 2, means that we are moving from right to left. But if we choose minus pi over 2, it means that we are already at the left position and we are moving to the right side. And 0 and 6 centimeter means that 0 is we visualize it at the left side, and 6 centimeter always are on our right side. So it is going to be indeed minus pi over 2, this guy here. So phase constant is going to be minus pi over 2. Let me just add another page. Perfect. So now we can complete our equation of position as a function of time. Xt, amplitude is 0.10 meter, cosine of our omega or angular frequency was pi over 2 radian per second, time minus pi over 2. Right now, we need to plug the 6 centimeter in our equation to find out the time. So let's convert 6 centimeter to meters. It's going to be 0.006 meter. 0.06 meter equals 0.10 meter times cosine of pi over 2 rad per second, time minus pi over 2. Let's just divide 0.06 meter by 0.1 meter. It's gonna give us 0.6. We move cosine to the other side. It's gonna be our cosine of 0.06 equal pi over 2 rad per second t minus pi over 2. It's our cosine of 0.06 going to give us 0.927. Here is going to be plus and minus, plus and negative, because whenever we try to find out the arc cosine of a value, our calculator always shows us the positive value or the negative value, but we must always keep in mind that there is always two possibilities on the reference circle. Equal pi over 2 rad per second time minus pi over 2. So for the possibility A, which is positive, we're gonna keep the positive 0.927 equal pi over 2 rad per second time minus pi over 2. We move pi over 2 to the other side. It's going to be 0.972 plus pi over 2 equal pi over 2 rad per second time. Let me just plug it into my calculator. It's gonna be 2.54 equal pi over 2 rad per second time. So the time is gonna be 1.618 seconds. Let me add another page. So the second possibility going to be the minus 0.927 equal pi over 2 rad per second time minus pi over 2. We move minus pi over 2 to the other side. It's going to be 0.927 plus pi over 2 equal pi over 2 rad per second multiplied by time. Let me just plug it into my calculator. It's gonna be 0.643 equal pi over 2 rad per second time. We are going to divide this value by pi over 2. 0.643 divided by pi over 2. It's gonna be 0.41 second. So one of the possibilities were 1.61 second and the other possibility is 0.41 second. Since the total the period is 4 seconds, this value is more likely to be the positive answer, because it just imagine the total time, the total amount of time to make a full rotation is 4 seconds, and we moved from here to a certain position here. It's just 0.41 seconds, but 1.67 is a huge number. It's almost, we moved from here to somewhere here. So 0.41 second is the answer to this question. Thank you for listening.